My name is Girish Sood, and I'm the Senior Product Manager for Amazon Kinesis Video Streams. And I'll be joined by Frederic Delacourt, who's Senior Director for Technology and Services at Wyze Labs, and by Tal Yuan, who's the Director of Technology at Wyze Labs. In this session, we're going to talk about how do you simplify video streaming for millions of smart home cameras. A quick look at the agenda for the day. First, we're going to cover how camera devices are used in smart homes and the challenges that exist in building scalable, reliable media services that support those camera devices. Next, we're going to cover an overview of Amazon Kinesis video streams and discuss how Amazon Kinesis video streams simplify that complexity using managed services. Next, we got an exciting announcement. We launched support for WebRTC-based live peer-to-peer two-way media streaming support as a managed capability in Amazon Kinesis video streams 2 days ago in general availability. We'll do a quick demo of that capability between a web application and a mobile application, which you can easily extend to camera devices too. Finally, we'll hear from Wyze Labs, and they'll come up on stage and discuss how they use Amazon Kinesis video streams and other AWS managed services to simplify the media streaming complexity for their smart home camera devices. Let's start by looking at what is a smart home. It is a dynamic and rapidly growing market segment. Consumers are consistently looking for new ways to simplify their life, to make things easy for them, to make their life more comfortable and entertaining, and also to make them feel secure and safe in their homes and help them protect the things they love and care about. On the left, you see home automation and entertainment use cases, things like lighting system, smart appliances, smart voice assistants, media and entertainment systems. On the right, you see home security and monitoring use cases, where security cameras, video doorbells, smart thermostats help you monitor and secure your homes. Underlying all of this is the networking equipment that you use in your homes, the Wi-Fi routers and cable modems and so on. As you can see, enterprises are consistently trying to develop new solutions and devices that deliver on that growing customer demand for ease, comfort, entertainment, security, and safety, and within which they use devices with multiple sensors, different edge and cloud computing technologies, and machine learning technologies. The focus of this discussion is going to be devices that use camera-enabled sensors, things that generate media data, and how you build media services around those devices. So let's look at what are the basic requirements for a camera-enabled device. Like any other sensor, it generates data. It's very specific data because it's time series, it's audio, video with complex encoding, decoding types. So you need to stream and capture that information from those sensors into your applications and service. Second requirement that comes in is once that data hits your applications and servers, you want to durably and securely store that information. It's time series information, so you need to build an index on top of it. You would want to encrypt that information. Once that information is available in your servers and applications, then you need an easy way to retrieve that information back for purposes of playback or custom processing. Beyond the basic requirements, this advanced requirements is what make the smart home camera even smarter. One, you apply machine learning on all of that data that you've captured. This machine learning comes in the form of detecting events and interesting insights that help customers meaningfully process all of that information that has been captured. Next, you want to connect all of these information that these camera-enabled devices have captured with rest of the smart home sensors. For example, if the door lock sensor goes off, the camera in the home should know that I need to start capturing the information. or if the voice assistant detects a sound, which is in an unexpected situation, the camera should start capturing that information. If the smoke alarm goes off, the camera can look at that information, apply machine learning, and understand the severity of that smoke event to notify customers. So this connection with this entire smart home devices that are present in a home is what make things even smarter. Let's talk about what are the streaming requirements that you'll have for this, purely in terms of what kind of services and infrastructure that you would need to build to support the basic and the advanced requirements. First, you need media services in the cloud that can securely ingest all the information that is being captured by these camera devices. It'll require instances like network load balancers, media processors, compute instances, and different other services to accept all of that information. Next, you require a durable and secure storage mechanism where that information that has been captured is being processed and now stored so that it can be retrieved on demand or in real time. That information needs to be indexed and encrypted. Next, you require playback services to deliver that video and audio to mobile and web devices. Finally, you require processing engines and compute instances on top of your media storage infrastructure to process that information for machine learning or other custom processing, things like generating thumbnails, shareable clips, video summaries. So this all looks easy. Where is the complexity in this entire media services design and architecture? First, as some of you who are familiar with media streaming can attest that there are multiple media streaming technologies and protocols that exist out there. There's RTSP, RTP, RTMP. I can go on for another 5 minutes just talking about number of media streaming protocols that exist out there. Each of these protocols are designed for specific use cases. They support specific media codecs. They have extensive support across different platforms, and they typically trade off between reliability of media transport versus latency that they can deliver. So for your use cases, you have to choose a combination of different media streaming technologies to build a compelling solution. Next, you need to support multiple devices and platforms. For consumption, you're looking at supporting Android, iOS, different versions of those, different mobile platforms, set-top boxes, TVs, different playback consumption platforms. Similarly, on the device side, you're looking at a combination of SoCs, media encoders, operating systems. So you are working through a complex set of media generation systems and media consumption systems that you need to support for your smart home camera products. Next, you have to build and operate a reliable and secure media infrastructure for all the media services, which needs to elastically scale to support your demand as you get more customers using your camera devices. Finally, you need very specific video streaming expertise within your engineering teams. Let's talk about how does Amazon Kinesis Video Stream simplify all of this complexity. Amazon Kinesis Video Streams is a fully managed streaming service specifically designed for camera-enabled devices. It provides managed services for 3 basic things. It securely ingests video and audio and other time series media data generated by these camera devices. It gives you simple APIs to ingest that information. It scales all the infrastructure behind ingesting that information, and it ensures reliability and security of data transport. Next, it provides you a durable and time-indexed storage for all of your media needs. As the camera devices generate data, and it streams into the Kinesis video stream, the data is automatically time indexed, both on the time it was captured by the camera and the time it was received by the service. Next, it provides easy APIs for consuming that media in real time or on demand. And that consumption can just be for playback or for any other custom processing where we deliver raw video frames. Let's break all of these 3 steps that I discussed and go into a little bit more detail about how Kinesis Video Streams does that. On the ingestion side, Kinesis Video Streams has free and open source libraries which can integrate with the camera device directly or with a gateway or a hub which can accept the stream from the camera. It'll then repackage that information, take care of interacting with the media backend, and secure the reliable and secure transport of that information. It takes care of network pressures and buffer information and managing jitter buffers for media. Again, the initial complexity that we discussed was support for multiple platforms and hardware devices. Kinesis Video Stream Producer SDK libraries are available in different forms which are compatible with multiple platforms. The base of the SDK and the library is written in a platform-independent way in C. On top of it, these functions are exposed in C and C++. These functions specifically include state management, network buffer management, reacting to network outages. How do you package that media into reliable chunks of individually playable fragments? And all those APIs are easily exposed in C and C++. This C and C++ layer is specifically designed for hardware manufacturers or people who are comfortable using firmware level coding. On top of it, all of these capabilities are then packaged into GStreamer as a plugin. GStreamer gives you a managed media pipeline where you can do custom processing within that media pipeline. These GStreamer plugins are available for Windows, Linux, Mac OS, and Raspbian. For people who just want to start a quick interaction with the Producer SDK, all of this is also packaged as a Docker container that you can deploy on your devices or on an EC2 host to start streaming. This is the Producer SDK is also available in Android. Let's talk about storing and indexing the media. Kinesis Video Streams gives you a managed resource called a video stream. This video stream gives you an isolated, managed way to store the information that is generated by the camera. The key word is isolation here. If you build a flat storage system and you have hundreds and thousands of cameras putting data into that single storage base, you are building indexes, you're building security systems, you're building access controls on top of that. Video stream is a resource that can map directly to the data generated by the camera, and camera puts that information into that video stream. And streams from different cameras don't cross each other. Like any other AWS resource, you get the access control, the auditing, the monitoring capabilities that are available for all AWS resources. In addition to that, you also have easy APIs to specify how long the data needs to be stored in a specific stream. Consider, for example, you have a freemium base of customers where the data needs to be stored for, say, a day, and you have a set of subscription customers where the data needs to be stored for 30 days. So for the streams that are allocated to your subscription customers, you go ahead and easily update that API. And as your customer base shifts between these two groups, you don't have to think about managing their storage. It becomes an easy API-based interface to manage that storage policies. Last but not the least, all the data streamed into KVS is encrypted on the wire and at rest using your account KMS keys. Now let's talk about, you've ingested the data has been stored. How do you process that information? So 2 use cases for processing. First is machine learning. Kinesis Video Streams gives you 2 APIs, Get Media and Get Media for Fragment List, which gives you access to the video in real time or on demand for processing that video with machine learning. And you have different options to do that. You can use Amazon Deep Learning AMIs. Kinesis Video Streams integrate with SageMaker by a feature called Kinesis Inference Template for SageMaker. This is a Fargate-based templateized input which extracts video frames in real time from a video stream and passes it to your SageMaker-hosted ML model and lets you then draw those inferences back, which is, again, time indexed back to the video. In addition to this, you can also use Kinesis video streams in conjunction with Amazon Rekognition Video for a fully managed ML service. We talked about ML. The other basic use case for video is once you've streamed that, someone wants to watch it. For that, Kinesis Video Streams provides a managed API for HTTP live streaming, commonly known as HLS, and for dynamic adaptive streaming over HTTP. Between these two protocols, you cover a wide gamut of web and mobile platforms which have inbuilt support for these protocols. So your player experiences become much simpler to develop and maintain. These two protocols also support a wide gamut of audio and video encoding technologies. So as your camera generates that information, you don't have to transcode and process that information in the cloud before they can be played on mobile and web platforms. Let's talk about something interesting now. 2 days ago, we announced support for WebRTC-based live peer-to-peer two-way media streaming support in Kinesis Video Stream as a fully managed capability. What does this capability get you? With this capability, you can stream ultra-low latency two-way media and audio and video and data streams between connected devices and mobile and web applications. It is real-time, and it's two-way, so you can enable interactivity. It is standards compliant with WebRTC. That means that you don't have to build plugins and player applications for your mobile and WebRTC compliant mobile and web applications. Finally, it's fully managed, so there is no infrastructure for you to scale and manage and operate. You easily get access to API to build an interactive media experience for your connected devices. Let's talk about what is WebRTC before we talk about how does Kinesis Video Stream support WebRTC. WebRTC, unlike other media streaming protocols, is not just a streaming protocol. It's a collection of different technologies. First, it has technology specifications for signaling. Signaling, let's put this in context of an example. You have a video doorbell at your home, someone rings that doorbell, you have a mobile phone on the other side, which then wants to answer that doorbell event and have an interactive communication with the person on the other side of the doorbell. Within that process, what signaling enables is when you answer the doorbell, the mobile client sends its media capabilities to the doorbell via something called signaling messages. This includes things like media encoding capabilities. What resolutions do I support? Once the signaling mechanism finished, it is supported by Session Description Protocol, commonly known as STP. Once the media exchange happens, then comes in the connectivity layer. Then the mobile phone and the doorbell starts finding what's the shortest and the most compelling path for them to connect to each other over internet. If devices are behind NAT, then they try to go through through protocols such as STUN to identify their public IP address so they can punch a hole through the NAT and connect peer-to-peer. If peer-to-peer connectivity is not possible, then it relays the media through a turn endpoint, which becomes a relay service for connecting these two devices. Beyond the connectivity and the signaling piece, now these two peers are connected. They need protocol specification for media delivery, which includes SRTP for secure media transport and SCTP for data transport. You have arbitrary number of channels that you can set up between these two devices. Audio, video, and text information can transport. And finally, WebRTC specifies encryption standards, which are based on asymmetric encryption open standard protocols, and ensures the end-to-end media and audio exchange between the two peers is encrypted. So this is the flow that we just discussed. So you have a mobile phone on one side, you have the doorbell on one side. They are behind symmetric NAT. They send signaling messages to each other. Once the signaling messages are exchanged, they agree on the media capabilities. They punch a hole through the NAT through the stun to connect to each other peer-to-peer. If they are able to establish successful peer-to-peer connectivity, they can start streaming real-time, two-way audio, video, and media data. If the peer-to-peer connectivity is not available, then Turn helps you relay that media through the cloud. So how does Kinesis Video Stream support the WebRTC capability? First, as I said, it's a fully managed service which manages all the infrastructure on your behalf. So it provides managed infrastructure for signaling, stun, and turn. There is no infrastructure for you to manage, and this infrastructure scales elastically as your demand grows. Next, it provides open source SDK for camera IoT devices. This is an interesting thing to notice because these SDKs are purpose-built for IoT devices. The memory footprint considerations, the CPU memory considerations have been considered to run on extremely constrained hardware devices. Next, it provides open source client SDKs for mobile and web applications, and we'll cover all of these in a little bit of detail next. So the signaling service is again supported by a resource which comes in with all the goodness of AWS resource management, auditing, monitoring, and metricing capabilities around that. So that resource, just like video stream in this case, is called a signaling channel. WebRTC protocol does not specify how or what transport mechanism do you use for exchanging signaling messages. It could be HTTP-based signaling. It could be WebSockets-based signaling. It could be traditional protocols like SIP, which can be used for exchanging these signaling messages. Kinesis Video Streams uses secure WebSockets. We also have APIs for very specific use cases for HTTP for exchanging signaling messages. It's purpose-built for smart home. The signaling service is purpose-built for smart home. What do you mean by that? You can do peer-to-peer signaling in different ways. The approach that Kinesis Video Stream takes is we work in a master and viewer connectivity model, where master is your device which connects in and listens for other viewers to connect to it. The typical example could be your home security camera. It's waiting in while the rest of your family members can at any point of time log into that camera to start live streaming. So the master viewer concept is designed for IoT-specific use cases. Again, we discussed what Turn does. Turn does secure relay. It's a managed service which elastically scales. Similarly, for stun is a global endpoint that you get for punching a hole through the NAT. The embedded SDK is a purpose-built SDK for IoT connected devices. I talked about how we took specific consideration of allowing that SDK to run on constrained devices. The memory footprint of this SDK, or the flash footprint of this SDK, is about 4.5 megabytes if you have the available libraries. In contrast, the web-based WebRTC libraries are in excess of over 100 meg. This SDK supports features like trickle-ice for faster connectivity, where you, rather than waiting for all network connection candidates to be identified, you start with the first candidate. So you can immediately start streaming while you find better connectivity paths. It supports H.264 and VP8 for video, G711 and Opus for audio. It's standards compliant, and if you're familiar with web and mobile applications that you use for building WebRTC application, you can bring that same knowledge, and the same interfaces are supported on IoT devices too. On the client-side SDKs, these are shim-layer SDKs in JavaScript, Android, and iOS, which work with inbuilt WebRTC capabilities in browser and mobile phones and allows you to connect on an API with easy APIs to the KVS signaling service. We talked about standards compliance. A use case that we have for that is integration with Alexa. If you have an Echo Show at your home, if you walk up to it and say, Alexa, show me the front door, it'll use WebRTC to send an offer to your Alexa skill. The Alexa skill will then send the offer to the Kinesis Video Stream signaling endpoint, which has a purpose-built HTTP API to support that. The offer will be sent back to the video doorbell where the Kinesis Video Stream's WebRTC IoT embedded SDK is running, and the answer will be generated. And now the Echo Show is connected to your video doorbell. Once it's connected, the two-way audio and video streaming can begin. Two-way audio and video streaming are an important part of getting Works with Alexa badge. So WebRTC facilitates that capability. Let's do a very quick demo. I'm running a web application on my laptop. Great. You can see we defined a signaling channel, named it our session name. We're going to decide what tracks will this streaming session support. It's audio, video, data channel. We're going to decide the resolution. And we're going to decide what NAT traversal technology we're going to use. Stun and turn if you're behind asymmetric NAT, which is likely in our case because I'm behind corporate network. Turn only if you want to relay the media through turn, or just disable it so that you only connect peer-to-peer. Then trickle ice as a feature for faster connectivity. And I'm going to start the master. It's going to show me in a minute. As you can see, on the left-hand side is my own webcam, where this is integrated with the browser's inbuilt WebRTC stack. I'm going to now run the same signaling channel on my Android phone, pointing to the back camera, and start a viewer. Now my Android phone will send an offer, and now you see that we are connected. The connection time was extremely fast, and as you look at the latencies, you can see we get to hand-wavy latencies here. In addition to audio and video streaming, I can also send textual information as I send a test message from my phone, and it just appears there. Great. With that, I'll invite Frederick Delacote on stage and talk about Wyze Labs.
Good morning. Okay, Wyze Labs. So very first thing is I would like to introduce Wyze Labs and who we are. So basically, we're a Seattle startup. We started about 2.5 years ago. And our goal is to provide what we call a convenient and enjoyable IoT lifestyle. It's a big term to basically means that we want to create products for the home and for people that are easy to use and accessible from many different points of view. The first one is, of course, from a price point of view. So we're trying to get the price as low as possible and still being profitable. The second aspect is reducing the complexity, the technology complexity, because we're not all engineers, and a few people have sometimes some difficulty just setting up the system or being able to use it properly. So we're making great investments in making sure that all the cameras, all the products that we're creating are very easy to access, very, very easy. So when we launched 2.5 years ago, we focused on the first product, which is now our hero product, which is a smart IP camera. It's called the Wyze Cam. It's a 2x2x2 inches cube, and it packs a bunch of features, as you can see with the advertisement that we had for the launch. And yes, $20 is the price for the camera with 14 days of cloud storage for free included. So when we launched, we were expecting some level of success, but it went way beyond that. So while the camera was slowly disrupting the smart home camera market, we've accumulated over 2.5 million customers in the last 2 years, which means over 3 million devices that have been activated to this point. We've got some pretty high numbers of daily active user, over 500,000 every day. And this translates at the end into a technology that has to scale, that has to be able to support a lot of requests. So for example, the cameras are generating, on average, about 3,000 TPS per day. Well, per second, technically. And we can go up to about 5,000 TPS within a day without any problem. So how did we approach the development? Being a small company, I mean, we're a startup. We don't have necessarily a lot of resources. And the way we tackled it is by looking overall at, if we take the full set of features and services, and let's assume that puzzles represent that set, then you always have in that set two pieces of technology. You've got the one that you have to have, which is a commodity, like think about login. You're not going to be innovative in login. You're going to reuse some OAuth. You're going to reuse some of the standard component. And then you've got all these other pieces, which are the blue ones, that are the one that differentiates you, the one that makes the product what it is, and it's specific to your company. Well, we had a fairly nice set, and we thought, that it was very differentiating. And then last January, AWS and the KVS team approached us and said, we got something that you think you might be interested in. Would you mind having a look? And they gave us a demo, and suddenly it strikes us. It was very obvious that the piece that they were showing us was, they were attacking directly our differentiators. The things that we thought we were good at, they were telling us we can do the same thing and sometimes better. So, we fell back on best business practice, which is you have to focus on differentiating sets. As a small company, you have to make a difference with every single investment that you're doing. And anything that's commodity, you're going to have to push it to your suppliers, which means that it was becoming very obvious that KVS was the choice for us to go forward. So what we did is we worked very closely with the team, and we integrated everything. We took KVS, integrated in the camera, and we're starting to now get the benefit. And the very first benefit that we have is that the team and the engineers that we had for supporting those 5,000 TPS, we've been able to reallocate them. And we've been able to add more differentiating features. So that's how we've been able to introduce new capabilities like person detection at the edge, directly in the camera. We've been able to make that available for free. And we're continuing the innovation, looking at pushing the boundary. And we know that all the basic service of streaming, of establishing live views, and all these things can be performed by KVS. So enough with the general talk. I'm going to ask my coworker, Tao, to come, and he's going to get into the technical details on how we achieve some of that. Thank you.
Good morning, everyone. My name is Tao Yuan from Wyze Labs. I'm very happy to be here to tell you a story that we worked together with the KVS team to enable a new scenario for our customers called complete motion. And then a little bit history about our project. When 2 years ago, when we first released this product to the market, we have a feature called event detection. Basically, it's like when the camera detects an event, it's going to send a 12-second video to the cloud, and then it's like let the customer to view after in the future. And then this slide is the architecture that we have for the requirement. It is very simple. When the camera detects there's an event, and it's requests an URL from the Wyze cloud, and then it's like submit the video to the Wyze cloud, to the AWS S3. And then when the app is trying to access, it is going to request a URL, and then download the file, and then playback. So everything seems very simple, straightforward, and our architecture is simple, and then get the job done. However, over time, we actually have more requirements from the customers. customers think like, the 12-second video is not long enough to capture the whole motion. So they would like to have more videos to store in the cloud. And then we have 2 more requirements. So we're going to have our videos to be extended to up to 5 minutes of length. And then with this requirement, there's a subsequent requirement, which is to view the video while the event is happening, because nobody wants to wait in 5 minutes and then to view the videos. So with these 2 requirements, it actually adds more challenges to our existing architecture. Our original solution is file-based. So a 12-second video is 1 meg file in size, which makes upload and download pretty simple. It happens in seconds, which is not noticeable by the customers. However, it's like when we extend to 5 minutes, the file could be 25 megs or 50 megs, it's like in some cases. In this case, uploading 1 file to the cloud and then download to the cloud will be much harder, and also it could cause a long delay. That is very bad user experience. So in our case, you can see that there is 2x in our original solution that we will not be able to implement for the new requirements. And we need a new solution. Yeah. So we have explored a few solutions before we implement the final one. And then the idea is to get the longer video file, break them into smaller chunks called fragmented videos, and then like when replay, we generate a playlist and then download them and then replay. So we have a solution by ourselves. This was what was architected. Yeah. And then you can see the red pieces are the ones that we need to add into the system. Yeah. And then so from the bottom 2, so from the camera side, the camera is going to, when an event happens, the camera is going to slice the video and audio into like fragments and then upload to the cloud. In this case, the upload actually is a much complex task because it could be like dozens or hundreds of small chunks to be uploaded. You have to think about buffering, sync, and then error management and a retry and all kinds of complications. So this makes our system could be a lot more complex. On the other hand, like on the cloud, we have to do some more extra work as well. We have to do stream management. We have to do more of the security management. And also, when we generate the playlist, we have to have like the clouds generate a playlist. And there is one hard part, which is generate the playlist on the fly. In the live replay mode, when an event is happening, and then where the customer wants to view the event, and then we have to generate a playlist on the fly, which is a very dynamic task. We need to be very precise to get everything done. So while we were thinking about this architecture, we were a little bit concerned about the complexity we introduced into the system. And then we're not sure whether we could implement everything in a safe, reliable, and a scalable way. And then, so while we're exploring, so it's we're very happy that we have a Kinesis team contacting us. Our 2 companies are both Seattle-based. Our offices are about 20 minutes away from each other, which makes face-to-face discussion much easier. And I want to thank Garish and his team. It's the multiple discussions for architecting our solution, potential solution, and also helping us integrate KVS into our system. So this is our new architecture with the KVS. And then you can see we don't have the red pieces anymore. The work is still there, and the idea is still about the same. So we're going to break a large video into smaller chunks and then regroup them during replay. And then the idea is to have Kinesis teams, their managed stack, to do all the heavy lifting work and then keep our solution simple. Because KVS is designed specifically for the streaming case and also stream replay case, which is specifically exactly what we need. And then why don't we leverage what has been built in KVS and then leave our system much simpler? So you can see from the camera side, when we have an event detected, and then the camera is going to call KVS APIs and then be hands-free. That means like the KVS APIs are going to do all the work for submitting the videos, and then it's like do all the packaging, retry, error handling, everything. Yeah. And then for our cloud, it's like it's also a lot simpler because we leave the security management to IAM with AWS IoT. And we also like, have the playlist generated by the KVS API. So when the app is requesting a playlist, our cloud is going to forward the API to forward the request to KVS and then generate the playlist. So just a recap for the benefits, ingest and digest is much simpler, and we don't have to do stream management, security management, and we don't have to worry about scaling because everything is taken care of by KVS. And also, this is a much suitable solution for us to expand in the future with SageMaker and everything integration. So with WebRTC release this week, I would like to congratulate the KVS team releasing WebRTC. This is a big milestone. And then we are also thinking about how WebRTC can help on our architecture to make us go further. Yeah. So this is our current architecture. This is a standard, it's like IoT architecture. We have the mobile device, we have the Wyze cloud, and also we have the IoT device. And then for our streaming device, we do have a streaming capability. And then right now, we're using a third-party implementation for streaming, which works fine. However, the proprietary protocol makes it harder to integrate with other systems. As you know, that we have the MP4 files, the video files in the system for video replay. And then when in the future, it's like later on, and then when we integrate with Alexa, and then we have to introduce a new component to make Alexa connection. Because while the streaming server can provide RTSP to the Alexa clients, and then we couldn't do it directly from our third-party implementation. So you can see from the picture that the connection, the overall system gets more complicated. And when we introduced for Google Home integration, we add more lines into this picture. And then we have the Wyze streaming server, we modified the server, and then provided MPEG dash for Google Home clients. So you can see that the system gets more complicated. And also, there are some needs that we couldn't meet with our current infrastructure. So it's like two things. One is the two-way audio, because both RTSP and also MPEG dash are one-directional streaming. So we couldn't do two-way audio. Secondly, there were lots of requests for those devices to access the stream locally if all the devices are in the local network. Right now, with our implementation, the Wyze server is sitting in the cloud, and then even if the devices are on the same network, we have to have one extra travel to the internet and then coming back to the system. And this is just like the impact for our client, for our app, and also for our camera. The app will need multiple players because we have different implementation for proprietary protocol, for MP4 play, and then others. Yeah. And then for our cameras, we have to have multiple IoT registration because it has different systems. So how can our WebRTC help us? So first, we can have WebRTC to help us doing streaming. Yeah. This is what WebRTC is known for. And second, because we know that KVS can manage playback, and that we can put WebRTC and KVS together to help us manage playback. And also, both for Alexa and Google Home, they can support WebRTC to be the streaming protocol. In this case, we can pretty much make our infrastructure a lot simpler to have WebRTC to be the main protocol for us, and then make our system a lot simpler. And with this, and we also enable the possibility of doing two-way audio, and in the future, with extra work, we can possibly do the local connection. And then on our app and our devices, we only need one player, which is taking care of WebRTC, and also one devices will have only one IoT registration. So we like this architecture better. So that concludes my part, and I'll give it back to Girish. Thank you.
Well, thank you, Tao and Frederick. I couldn't have said it better, how simple things become with managed services. If you recollect, in the beginning, we talked about 5 core complexities, managing multiple streaming protocols. And Tao talked about that RTMP, MPEG-Dash, RTSP, custom protocols, MP4 file downloads. There's this whole gamut of things that you have to support for different use cases. Next, we talked about multiple platforms that you need to support with these technologies. Google Home, Alexa, your own mobile and web applications. And then we talk about how you focus your energies on building differentiated features while leaving managed services to take care of building, operating, and scaling all that infrastructure for you, while your engineering teams focus on differentiated features. To put it all together, we talked about Kinesis video streams as a managed service, which provides all the core use cases for home security or camera-enabled smart home devices. It provides low-latency streaming and two-way interactivity with WebRTC. It provides a secure media storage, which is time-indexed for storing all the information. And then it provides APIs for playback and custom processing. With that, we're going to open up for questions. When you have a question, if you can raise your hand and we can get the mic around.
Microphone.
Can I do this, so what we do is we have a mobile app which connects to various cameras, and we have a home and office automation system out there. And what we do is we take any kind of camera stream, say DVR and VRI cameras, and we have a Raspberry Pi in between, which is our gateway, which controls all our hardware, lights and everything. So can I use Kinesis on that particular Raspberry Pi and stream all this, where the cameras are connected via RTMP, use Kinesis to upload and manage the whole?
Absolutely. So on the Raspberry Pi, you will run the Kinesis. If you want to ingest that information into the cloud for storage and indexing, you can run the Kinesis Video Stream HTTP SDKs, the producer SDKs library that we talked about. If on the Raspberry Pi, you can run that as a GStreamer plugin because it's available in Raspbian. It can accept RTSP stream, chunk it out, store it, and now you get a managed solution for storing information. If you have use cases for live playback, then you install the Kinesis Video Stream's WebRTC SDK on the same Raspberry Pi, and it can support RTSP ingestion in and then make your mobile and web playback easy. Okay. Other questions?
Yep, there's a microphone, if you don't mind. Right there.
As I know, there is
Yes.
costs. When video is coming out from AWS to clients, how did you deal with all the costs? Because the video streaming data is not that small. I mean, the video file is so big, but how did you deal with about the price when the video file is coming out from the AWS to client?
So it's a cost-related question on consuming all of the video.
The data, when data is going to the cloud, AWS cloud, there is no cost.
So I'll try to answer that question. I think I understand. You're talking about connectivity costs. So on any AWS service, when you consume data outside of AWS to internet and send the data out to internet, the standard data transfer charges that apply. If you look up any service or go to the Kinesis Video Stream pricing page, you can see what the transfer pricing is. Go ahead.
Sorry, forgot one more question. Can I use Kinesis video streaming to talk like a two-way conference call or video call between two mobile apps?
So there's a connotation in there. The conference call can be a very broad thing. It's meant for peer-to-peer streaming.
Okay.
If you want to do multi-party conferencing, Kinesis Video Stream WebRTC is not designed for that. It's designed for peer-to-peer connectivity. So if you have a use case where you want to connect with another person and do two-way interaction, audio, video, yes, you can do that. But if you want to create like 4 people connecting together, I'm connected to all 4 of them, they're simultaneously speaking, that requires very specific WebRTC technologies like multiple control units, selective forwarded units. That's not something that Kinesis Video WebRTC is supposed to do.
Thank you.
Go ahead.
So it's a question about the cameras and how you've integrated it. What kind of hardware requirements are necessary? Because you mentioned H.264 and XBP8, wasn't it? They're quite intensive codecs. How have you done that?
So most camera devices support H.264 encoding by default. For example, I'm going to talk about the Kinesis Video HTTPS streaming SDK, the producer SDKs first. The C SDK basically accepts those frames, packages them into a streaming compatible format, which is Matroska, and then manage the network interaction. So there is no encoding that's happening. It's repackaging, so it's not resource or CPU or memory intensive. The memory that it takes is based on amount of buffer that you want to keep while the network interactions are happening. So if the camera is generating information and network goes out, how long or how much information do you want to hold? So that's memory requirement. On CPU, it's not intensive. For flash or actual storage requirement, the Kinesis Video Stream C SDK, for example, which Wyze currently uses on their hardware, takes less than half of a megabyte of space on the device.
Yeah. And
So-
specifically in the...
sorry, go ahead.
Go ahead.
So just one thing for the H.264 encoding, yeah. Most of the hardware manufacturer will take care of it, yeah. For us, it's like for us providing the camera, it's actually the capability comes from the hardware manufacturer.
Yeah, and by hardware, we mean the CMOS, actually what comes out of it is an H.264 encoded string.
Any other questions? Go ahead.
How do you handle the verification of the source valid string of the string to know that it's kind of the correct source and not like a fake source?
Got it. Got it. So the question is, how do you authenticate and authorize the source of the information before they can integrate with the Kinesis video stream asset? There are multiple ways to do that. The simplest and the easiest way is using Kinesis video, using AWS IoT. If you have AWS IoT generated X509 certificate, you can install that on your device, and Kinesis Video Stream Producer SDK libraries integrate with that certificate to generate streaming session tokens and do the authorization and authentication process, which are frequently updated on a periodic basis so the session remains secure. So that certificate becomes your identity, which you can then control using different IoT services in the cloud to provision and authorize and authenticate these streams. There's a detailed documentation for that on Kinesis Video Stream's developer documentation guide. You can look at that too. Go ahead.
For CCTV, so most of the cameras don't support WebRTC. So does Kinesis support on this standard? So are you familiar with on this? On this is the standard for CCTV. It's basically very similar to WebRTC, so it's based on web services, RTSP, RTP. So most of the cameras in the market doesn't support WebRTC. So the 10,000 or more cameras this casino has don't use WebRTC.
Got it. So the question is more broader about WebRTC is applicable in IP security space. We think that WebRTC is an evolving standard. As the standard gets adopted across different platforms, we'll see how that goes. OnWIF, to our understanding, is a protocol. It's a standard by which different cameras can become compatible with each other, or with DVR and NVR systems. For media streaming, OnWIF is not a standard. The media streaming protocols that it uses are RTSP and commonly RTSP. So how WebRTC gets adopted within ONWIF is something that we see how the standard evolves. But our approach is it's a modern protocol which is natively supported and extremely secure and reliable as it goes across mobile and web devices. So we see a broad adoption within the smart home camera devices. As it pertains to enterprise cameras, as you refer to this casino, hopefully it'll follow the suit of how fast the smart home devices are evolving. Go ahead.
You said that you don't support the many-to-many situation, but do you support one-to-many?
Yes, we do support one-to-many. To a master, up to 10 viewers can connect at any point, right? So one-to-many, so 10 viewers can connect. Of course, every connection is a peer-to-peer connection. So your source device should be able to support 10 peer-to-peer connections. But the model is 1 to n, in which case n is 10. Go ahead.
So the GStreamer plugin that you had in the producer SDK, can it support an inference node that can be managed using IoT Greengrass?
So there are two parts to it. One is support for Greengrass, and another is support for inference engines between GStreamer. So I'm going to talk about the first one. So the GStreamer plugin for KVS is a sync plugin which just sits in there, which can accept H.264 frames, which if you have processed through an ML engine before, and only then that sync will accept that data. So you can, within the GStreamer media pipeline, set up a ML inference engine. A capability that KVS provides, or the APIs provide for that, is you can, if you have done ML inference on the edge, and you know that information, along with audio and video data, you can also add metadata tags to that video stream. And when that video stream gets streamed and stored and indexed in the cloud, that metadata information gets indexed along with it. So I'll encourage you to look at the metadata APIs in Kinesis video. On the Greengrass support, we have had some customers who have deployed the Kinesis Video Producer SDK into a Lambda executable and put it on Greengrass, but there's some solution architecture work that you'll have to do around that.
The second requirement is basically to maintain the model that's used in the GStreamer.
Got it. Got it. Yeah, we can discuss more about that architecture offline. Great. Others? Well, thank you for your time today and taking all the time on the last day of reInvent to come to this session. Just a quick reminder on the training and certifications that are available for the analytics tracks. We really appreciate your time. Please take the time to complete the survey. It helps us improve the quality of these sessions for you. Thank you so much. And thank you, Frederick and Tao.